P3-39 is in millimeters, and it has the note "consider a shell." This really doesn't lend itself, in my opinion, to a shell. I would lean towards sheet metal, and then we would be able to unfold this and actually manufacture it. So we've done this, I believe, in previous videos as thin features. Need to go back and check. I don't really remember if it was a sheet metal last time, but these last two pieces are really, as far as the assignment, these two pieces lend themselves to sheet metal. So we're going to proceed with that. If you drew it or already created it as a solid and did the profile and put the geometry in, that's fine. So one of the issues with previous models is that these holes on the front kind of intersect the bends, and that's always a little bit of an issue as we go through that process. So we'll see what we can do with it and then continue the build. Okay, so we'll start our part in millimeters. And thinking, there we go. Alright, so one of the things we'll need is our sheet metal tools. Those can be found under Insert, Sheet Metal. Here's everything that we really need, but I would rather just have the command manager pull it up with a sheet metal tab. So since I don't use sheet metal all the time, I'll turn the tab off, and kind of the same with weldments. Is we can activate it, we can use whichever command we need, and then go back and uncheck it. So again, the thing with the tabs is do not uncheck all of them. That would be an enhancement request for Solidworks, is make it so at least the sketch is always checked regardless. Something along those lines, that you can't turn all of these off because it's kind of a pain to get it to show back up if they're all unchecked. So don't do it. Anyway, the sheet metal item then, in the very early days of Solidworks, was called a thin feature. And let's see, I'm gonna go from the corner and up and over and back, and we'll put some dimensions on that. And we had 45 along the flat, 35 on the height, and 35 on the length, and then let's see, have 8 from the center. Not quite seeing that one. Pull it back in and get it to where I can focus on it. So 8 from the edge. Now there we go. 18. That's kind of a weird place to put it. 18 from the base up to the top of the flange. Okay. So we'll double click on that. Once it's all highlighted in blue, I can overwrite it. And so the issue with making this as a solid part is the gap, the support. There's really not a lot of material in there. So even at a 5 millimeter, let's see, material thickness 5 millimeter with rounds of 3 millimeter, well, that's not quite gonna work. We'll get pretty close. I think 3 millimeter on the interior will be okay, but we're really at the point of being able to bend this. So the other issue is having the offset fingers or brake dies to be able to get in and produce this geometry. So machining it's kind of an issue. Getting it to bend is also going to be a little bit of an issue with that small opening there. So we'll get it into the design. And so in the early days of Solidworks, as I started to say, we would go into an extrude, and this would be a thin feature. We would have the 5 millimeter thickness, it is going to the inside. And with auto-filleting the corners, then I think it's the interior. We would have 3 millimeters on the interior. Alright, so that was kind of limited in its scope and what we could do with it. So the sheet metal tool evolved pretty quickly and became a lot more powerful tool. So we have a base flange, which is going to act the same as our then feature. At 5 millimeters thickness, 197, about 3/16. Trying to remember, that comes out to, I was thinking it was 10 gauge, but I have to look at the table. So anyway, we'll go with the direction. We have an overall of 80, and I'm going to go ahead and make it mid-plane, just so when it unfolds, that's kind of at the bottom center. And the millimeters then, we'll go with 5 millimeters for the thickness. I'm going to rotate over and just make sure that it's interior bend, since our dimensions were to the outside. And then we have a bend radius of 3 millimeters. Alright, so that kind of pulls it back. Alright, and then the K factor is where we equalize the forces of compression on the interior and the tension of pulling the outside apart, and usually that's around 0.3. Depends on the material, but we'll that'll give us a good start. So as this bends and we're deforming this material, the material, as much as it grows on the flat stock, or grows or shrinks, we're trying to take that into an account. All right. And then auto relief, if we had corners meeting the base, there would be a option of a rectangular, a tear, or a knob round relief, and the ratio is to the thickness of the material. All right, getting more in detail, I jumped over the gauge table. We can put together more information, take material and do practice bends, and get those measurements to build into our gauge table if we want to get more precise. All right, so there's my shape, and that gives me the bent sheet metal. And we have a flat pattern. So just a quick check. Interior measures 3 millimeters plus 5 means that the outside would be 8. If we were to put a minimum of 5, this would shrink to just a sharp, which 5 millimeters is not going to, 5 millimeter thick material is not going to like. It is more likely going to fracture no matter how ductile the material. So we need enough of a bend radius that the material can complete without tearing itself apart. Alright, so then the flat pattern is a suppressed feature, and when let's see, well, let's just go back to the sheet metal and we will flatten. Alright, so that unflattens it, so maybe it was this one. There we are, there's the suppressed icon. So that unfolds. I need to keep my terminology straight. That flattens, and we can see where the bend locations are for each of those items. So again, 5 millimeters being pretty thick, there's some definite challenges here. So in our process, all of our geometry needs to be above the flat pattern, and anything that is below the flat pattern doesn't really exist in the model. It only exists in the flat pattern. So we'll see that here in a little bit with some of the hole locations. So I'm going to suppress that back or toggle with the flatten. And then because of the mix, well, let's see how far we can get with this. We'll go into a sketch, and then it's just like we're sketching with our solid geometry, or our regular boss base extrudes. I'm going to select the midpoint, control select the line, set a midpoint. That will help center it up. I could also, because I put it on the origin, have that symmetry. could drop in a center line and attach it to the center line. So we have a depth of 25. Oh, wrong way. Have a width of 50 to go with our depth of 25. And then the 2 hole locations, I'll go ahead and include those. And we'll make those equal. I could make these symmetric. So go Control 5 so we can see the top view. And then the holes are 8 millimeters for 4 places. They are 12 millimeters off of the front edge of our bend. So on that one, I want to do center point and Control select the center points and make those vertical. And then for interior, we have 10 millimeters off of the edge 4 times. Yeah, it seems a little closer, but let's see, 50 and 80, 15. Yeah, that's pretty much it. Let's see, the 50, actually, look at that, the 50 is going to the through pocket, and the tabs is actually a 40. Okay, so that's 2 places. So as soon as I notice that that gap closing up, then we'll try to correct for it. All right, go back into our features, Extrude Cut. We'll want to watch for the through all because now it's going to punch all the way through the object. So in this case, we could go up to next, or if I choose to stay with the blind in condition, with sheet metal you get the additional link to thickness. And then if the material were to change from 5 millimeter to 4 millimeter to 3 millimeter, it will stay with the thickness of the material. Okay, so that gives me the one result. And then let's go ahead and see what we can get with this geometry. I'll open up on the in face, and it's going to be the same type of process where I can select, Control select, get my midpoint. I think I'm going to go ahead and tie it to the upper geometry. I don't want that face, so those become coincident. And then the depth is shown as 12 millimeters off of the interior. So now that's still kind of a weird place to make the bend, but that would be 20 millimeters off of the front side. But I guess it depends on the ability to make that isometric dimension make sense. All right, so we'll cut through. This one can go through all. There's not anything on the side to conflict with. All right. So the issue here, let's just put the one hole in, and this is diameter of 8, 10 millimeters off of the edge, and 8 millimeters from the top. Alright, so right now it's above the bend in that flange, but as soon as I put in the 8, we're crossing over the bend. So that's going to lead to some deformation later on that we really don't want to deal with. So let's go ahead with an extrude cut. I'll give it the, well, I think the link to thickness. Let's see how it does. Oh, rotate it around here so you can kind of see that it's deformed the sheet metal as it goes through the curve, so that's really not a desirable result. So in that case, we're going to Control Z and get back out of the sketch, and actually on the undos, well, should have just gone ahead and deleted it. On the undos, we can go back to where we were editing the sketch, and let's see if we go yes. Alright, so got to watch that one because occasionally it will go back too far, and so always a little nervous when that happens. Alright, so before we jump into that last piece, let's go ahead and get the window through the back. Alright, I mentioned the center line. I'll bring it up from the origin, find the midpoint, make it vertical, and then it is 50 by looks like 12. And then its position is 10 off of the base. Okay, so that looks pretty good. Just double checking the numbers there. So this one can be an extruded cut, and it'll link to thickness, and we'll have the window. Alright, so to complete, so that I know that that's going to be a little bit deformed, or we're going to have to deal with it somehow. I want to go ahead into the sheet metal, and if we put it on the flatten, then it exists after the flat pattern. We need to unfold our geometry, so we will have a fixed face and then collect all of the bins. And even though I don't really need to collect all 3 bins, we'll go ahead and include them. So if there was any other geometry that we wanted, anything that spanned the bin, we would include it in this one bin. So kind of as a general rule, I only want to unfold once, or in certain cases the software has only let me unfold once. So I Control 5, we'll go into the sketch on the face. And I think I will just go with a horizontal center line and mirror. And we have our diameter of 8. Ten off of the side, and then 8 from the top. Alright, so where that passes through the bin now, we're going to make that cut. But now, and I didn't flatten it or unfold it with just the cut. And I know that it's still going to deform, but this ensures that when it's in this flat pattern and we're putting it on the laser or the plasma or EDM, whatever is going to cut this shape out, that we're going to get that geometry. So let's go ahead and fold this back up. So after we've created the unfold, then we're going to do the opposite and fold it back up. And so it finds the fixed face that we had previously. We'll collect all of the bends. I've never really tried it, but now the deformation is more of a teardrop shape. So, you know, going across that bin, we would still expect it, but it's a little more circular than probably what it was. Alright, and then our last process will be to create the fillet. And we still have the 3 millimeters. And I'll go find another bend so that I get the pop-up. And I'm looking pretty much for the combinations. Well, that would be everything. That's a little scary. So all of the concave 6 edges, the interior, the tops, the sides, I think that's the one I want. And we'll go ahead and accept. Alright, so that gives me the sheet metal part. When I go into the flatten now, I'm going to see those shapes and all of those radiuses. And then when I unflatten or suppress the flatten, it puts it back into our geometry. So sheet metal has a lot of powerful tools. By the time we go into the rest of our geometry, we can do quite a few shapes and make some really cool geometry.